Okay, so we're going to try and identify what's called the average rate of change of a function. Okay, so this is basically the procedure. It's actually really easy. If we want to identify the average rate of change of a function f on an interval, we have to be given an interval, and it's usually a closed interval from a to b, where a and b are both x values. So here you can see that the function f says what is the average rate of change of the function 2x squared minus 9x plus 5 on the closed interval from -3 up to 2. So this is starting at x is -3 and it's going up to x equals 2. Okay, so you have to understand this as an interval. So if this is the x-axis, here's the x-axis, okay? And all the way over here is negative infinity, and all the way that way is positive infinity, right? And, you know, we have -4, -3, -2, -1, 0, 1, 2, 3, right? And the y-axis is right here. So the y-axis is running through 0. That's our y-axis, okay? And y is basically what f of x is. It's the output values of f of x, okay? And so what we're saying here is this is a closed interval starting at -3 and going up to 2. So basically bracket here at -3 all the way up to 2. So it's saying on this interval, including all the x values between -3 and up to 2, okay, we want to know what the average rate of change is, okay? And we can do this with anything where we identify the first value as a and the second one as b. So this would be the a and this would be the b, where a is the starting point of the interval and b is the ending point of the interval, okay? And so then what we would be doing here is the formula. This is just a formula. If you can do this, you're done. You just plug the numbers in, you get an answer, fraction or whole number, whatever, or integer. So what we do is we plug the b into the function f, and we do f of b minus, then plug the a into the f function and get f of a. So these are output values, y values, okay? So we get the output of the function when we plug in b minus the output of the function when we plug in a, and we divide it by b minus a. Now this may look very familiar to you. This is based on the slope formula, m. You know, the slope is m. So this is like the slope of a line, okay? And even though this is a quadratic, what we do is we identify the average rate of change as the slope of a line between 2 points on this function. Maybe we'll get to that later. Don't get too bogged down in that. So it's based on slope. So slope is y2 minus y1 divided by x2 minus x1. Well, in this case, a is the x1. b is the x2. Those are both x values. If you plug x values into the function, you get output values, which are y values. So f of a is y1, and f of b is y2. So if we replace x2 with b, we get b here. Minus, replace x1 with a, we get b minus a. And if we replace y2 with f of b, we have f of b minus, and replace y1 with f of a, we get f of a. And so this is just the slope formula, okay? A y value minus another y value divided by an x value minus another x value. It's rise, it's vertical difference. This is a vertical difference divided by a horizontal difference. Rise over run, okay? Well, that's the concept. Let's just do it in practice. It's so much easier to do in practice than it is to try and conceptually understand. So if we want the average rate of change of this, we want f of a, which is -3, or sorry, f of b, which is 2. Sorry about that. F of 2 minus f of -3 over 2 minus negative 3. That's it. And so we just need to know what f of 2 is. Well, to get f of 2, we got to plug 2 into the formula, right? Let's do that over here. So what is f of 2? All right, f of 2 is 2x squared, so that's 2 times 2 squared. We're plugging the 2 in for x. 2 squared minus 9 times 2 plus 5. Okay? Well, 2 squared is 4. 4 times 2 is 8. Negative 9 times 2 is minus 18, then plus 5. And that gives us 8 minus 18, that's negative 10. Negative 10 plus 5 is negative 5. And so f of 2 is negative 5. Okay? So here, we're going to put a negative 5 here. Minus. Okay, now we need to know what is f of negative 3. F of negative 3 is, well, let's take our 2 and then put negative 3 in parentheses here, squared. 2, parenthesis, negative 3 squared, minus 9 times negative 3 in parentheses, plus 5. All right? Well, negative 3 squared, that's 9. 9 times 2, that's 18. Negative 9 times negative 3 is plus 27 and plus 5. So 18 plus 27, that's 45. 45 plus 5 is 50. Okay? And so f of negative 3 is 50. So we're going to do minus 50 over. Now, 2 minus negative 3, that's the same thing as 2 plus 3. 2 plus 3 is 5. And now we'll finish up. Negative 5 minus 50 is negative 55. Negative 55 divided by 5 is equal to negative 11. And that's our final answer. So the average rate of change of this function on the interval from negative 3 to 2 is negative 11. Okay? Let's try another example. Okay, so this says, what is the average rate of change of f of x is equal to 3x squared minus 27x plus 17 on the interval from 2 to 9. And so we're going to use this formula, f of b minus f of a over b minus a. In this case, a is 2 and b is 9. Okay? And here's f of x. So we want f of b, which is f of 9, minus f of a, which is f of 2, over 9 minus 2. Well, let's find out what f of 9 is. We'll plug 9 into this. So f of 9 is going to be 3 times 9 squared minus 27 times 9, may need a calculator for this one, plus 17. Okay? Well, 9 squared, that's 81. 81 times 3 is 243. So we'll have 243 minus 27 times 9. Also 243, that's convenient. Okay, plus 17. Okay. So this is just going to be 17. So f of 9 is 17, so we'll do 17 minus. Now we need f of 2. All right, well, to get f of 2, we're going to plug 2 in for x. We're going to have 3 times 2 squared minus 27 times 2 plus 17. Okay. All right, well, 2 squared, that's 4. 3 times 4 is 12. Negative 27 times 2 is negative 54. And then we're going to go plus 17. So 12 minus 54 is negative 42, plus 17 is negative 25. So this whole thing is negative 25. F of 2 is negative 25. So we'll put minus negative 25 all over 9 minus 2 is 7. 17 minus negative 25 is the same thing as 17 plus 25. Same thing as 17 plus 25. And so that's going to be 42 divided by 7. And 42 divided by 7 is 6. And so the average rate of change of this function on the interval from 2 to 9 is equal to 6.